Hi, welcome to Mr. Brudz's chemistry class. Here's Brandon, my assistant for today. Thank you, Brandon. Alright, so as we've previously covered covalent bonding, which is when electrons are shared between atoms, ionic bonds, where electrons are transferred between atoms, and we've covered Lewis dot structures of an atom, which is how we show the outermost electrons or valence electrons of an atom. So, today we're going to put it all together. So, Brandon.
Yes.
Alright, so we know that carbon and oxygen covalently bond with each other to show a covalent bond. So, what are some things you would think using a Lewis structure would work to show the sharing of electrons? The sharing of electrons between atoms.
Like if I had to draw it out on one of these,
Yes.
I would assume that the right pair of two on oxygen would lose one, and the top of the carbon would gain one. Is that what a covalent bond does?
No, not quite. So if you recall, so in a covalent bond, electrons are shared. So neither atom is losing an electron. They're both getting partial custody of the electron.
Okay. And how does that get shown in one of these? I don't know.
That's what I'm asking you.
I don't know. I don't know how that would get shown. Neither of them are losing one.
Correct. So
I don't know.
So we know that each atom has 4 orbitals.
Right.
And how many electrons can go in each orbital?
2.
2, correct. So what are some ways we could represent electrons being shared between orbitals?
Put them in both of the
Yeah, that's a way to do it.
Orbitals.
Yeah, that's a way to do it. So, could you draw for me carbon and oxygen and how you would think we would do a shared orbital?
Like draw how you got it on there, right?
Yeah, you can start with that.
So we go, oxygen is okay, and then draw how I think it would look.
Yeah.
But it's not gaining one, so adding one here doesn't make sense.
Right, the number of electrons are staying the same.
Right. In my dumb 8th grade mind, I would do this,
Okay.
and I would do this, and those would be my outermost orbitals.
Okay.
I don't know if that's right, but that's how I would do it.
Okay, you're getting closer,
Okay.
but this orbital looks a little over full.
Oh, it does. You're right. And this one is too.
Right. So
Okay.
So we're only representing one bond. So let's try and figure out how to join one orbital.
Okay. So this had 2 here, 2 here, and then yeah, it doesn't actually matter. This had 2. So this is it just this?
Yeah.
Oh, okay. Okay.
I'll show Brandon's work. Alrighty. So that's a way to represent a covalent bond. Now, a kind of cleaner way to represent that. So you have your carbon, and you have your oxygen. Now, when you show a covalent bond, you can just put them right next to each other, and you can represent the orbital in between the two atoms.
Gotcha. So as long as you have, you got what? You got 6 on oxygen and 4 on carbon.
Correct.
So as long as, that's 10. So as long as you've still got the 10 dots, you're good.
Yes.
Okay.
Because the
So
number
you can
of
just slam the letters together as long as you still have 6 dots, or 10 dots in there somewhere.
right.
Okay.
And then the number of dots in each orbital
Can only max out at 2.
can only max out at 2. And alright. So now let's take at representing an ionic bond.
Yeah.
Alright, so let's start with something very simple. So we have sodium, which has 1 valence electron, as you can see in your chart.
Yep.
And then we have chlorine, which has how many?
Hang on, let me find them. Sodium and chlorine. Chlorine has 7.
Correct. 1, 2, 3, 4, 5, 6, 7. Now, we know that the atoms always want to try and be at 8 valence electrons if they can.
Mm-hmm.
So when that happens, it's way easier because don't forget sodium already has 8 electrons in the smaller shell.
Right.
So when that happens, we would get an ionic bond because so it would be instead of sharing an electron. So all right, say chlorine and sodium did share an electron. So that would make how many valence electrons in chlorine shell?
Like total or the outermost layer?
Outermost layer of chlorine.
If they shared one,
If they shared an electron.
8.
8. So chlorine would be happy, it would be stable.
Yeah.
But what would that do to sodium? In
Well,
the outermost shell, ignore these ones.
they're sharing it, right?
Yes.
Okay, so it would just remain the same, right?
So, alright, so if chlorine goes from 7 to 8, then sodium,
Would have to drop 1. So it would have to drop 1.
right, because what would happen if they did share instead of stealing?
If they did share, that one would remain at 1, and that would remain 7, right? Or no?
So if chlorine went to 7 and to 8, then sodium would go from 1 to
0. 2?
2, right.
Where's the extra one coming from? You only have 1 to share. That math doesn't work.
So we'll show it by the orbitals. So sodium has 1. So chlorine has 8. And so sodium has this orbital 2. So chlorine and sodium both now have this orbital.
Okay, gotcha.
So
Okay.
the number of electrons stays the same, but each atom gains an additional. Now, if we're at 2 electrons in the valence, that's not close to 8. That's not very stable.
Mm-hmm.
So that's why we would not actually get a covalent bond between sodium and chlorine, because it takes way more energy to share the electrons
Mm-hmm.
than it would be to steal the electrons. So we have sodium with 1 valence electron.
Right.
We have chlorine, 7 valence electrons. So what are some ways we could represent the stealing of electrons?
Drop the one from sodium and give it to chlorine?
Yeah.
Okay.
And so, alright, so sodium loses an electron. What happens to the state of sodium?
It becomes negatively charged. Is that
By
what you're asking?
losing an electron?
It becomes positively charged.
Right. Because when it loses a negatively charged thing, like an electron, the atom now becomes an ion, so now it's positively charged. And so, how would you represent a positive charge?
With a plus.
Yep, a little plus. And then chlorine now has 1 more electron than it does protons, so it would be represented by a
Negative charge.
yep, by a minus.
Yeah.
And then this is something you might not necessarily intuit, but usually when something becomes an ion, we put it in brackets.
Okay.
So alright. So we did sodium chloride. So let's say, so I want you to diagram out. I don't know how that happened.
Diagram out.
Alright, so I want you to diagram out some valence electron bonding through the Lewis structures, and let's start with lithium and fluorine. How would you think lithium and fluoride would work together?
Well, so these are gonna bond, right?
Yes.
Okay. Just have.
So lithium
Yes.
has 1 valence electron,
One.
and
And
fluorine
this one has these.
7.
Yeah.
So so in order for each atom, to be filled with 8 electrons, do you think it would be easier for a steal or a share situation?
It would be easier for a steal situation.
Yes.
Yes.
So you have the atoms, so now show you the steal situation.
So this would become positive and this would become negative.
Correct.
And then apparently we bracket these.
Yes. So we'll show Brandon's work. Alrighty. So now let's take a look at another situation. What if we have 2 chlorine atoms?
Okay. My assumption is that they would be easier to share.
Yep. So then can you show a Lewis dot structure of the 2 chlorine atoms shared?
I don't know if it's necessary for me to circle this every time. I feel like it's just easier to show.
You don't need to, but if it's easier for you to to model that, then that's correct.
Yeah. Yeah, I would assume it would look like this, and these are being shared. Which means that so neither of them are losing or gaining anything.
Correct.
So what do they have any kind of a charge? They're just neutral?
They would be neutral. They
Just
would be
neutral.
uncharged because the total number of electrons in each atom is the same as the total number of the protons.
Okay.
Because as we know about the number of protons in an atom, that does not change. It's
Right.
electrons that are being exchanged, shared, etc.
Gotcha. So I don't need a plus or minus or anything like that?
Correct.
Okay. So yeah, that's what I would do.
Okay. Now, let's take a look. How would we do... Let's take a look at fluorine and oxygen.
So we got to get him as close to. We got to get him to 8.
To 8 as possible.
My assumption is that fluorine would steal one from oxygen, or do they both want to be as close as possible?
They both want to be as
Alright,
close as possible.
This is not a sacrifice for the greater good kind of situation.
Correct. They're both
Okay.
being greedy over electrons.
Okay. Then I guess that they would share, because this would go to 8, this would go to 7.
Okay, yeah.
Yeah. So they would share. So
Share.
they would just do this.
Now, oxygen is still not happy because it's a 7. So, what's something we can do to make oxygen happy?
Steal another electron from somewhere else.
Yes. So, say we have some more oxygen and some more fluorine atoms floating around in our little test tube. What can we do to make oxygen happy?
Bond it with another fluorine.
Correct.
Yeah. So it would look like. Well, I guess I'm going to do that. So it would look like this. And then these are
Yep.
together.
So as you can see, Brandon has made the connection that multiple atoms can be bonded with a single atom by sharing multiple shells. Alright, well, it looks like the class time is up for now. Again, thank you, Brandon, so much for helping
You're
me.
very welcome.
And we are all set.